Hi, so today I have this fitness tracker, the E6 HRC. It's from Fit, and this is a complete new unboxed tracker, and you may have read already about it. It's a fitness tracker that is really good to hack and to make it Arduino compatible, so you can use it with Arduino and can reprogram it with your own firmware, and I want to show it a little bit. So right now the screen is on, but there's a screen protector behind it. You can see if I touch it that the for example now it will try to get the heart rate, and here is the time again. But that's not the reason we are here today. I want to show you how I add the SWD port to the USB connector. First we have to take it out, and we can see here the USB connector, and the two middle pins are not used for anything, they are just there. And normally you would plug it in any USB port and charge it up, but because they're unused pins, we will use them for the SWD port, and then we can program it via an ST-Link. And here I also made this adapter PCB where just the two middle pins are connected to the SWD clock and SWD EO. It's there descripted, but not so important. This way I can plug this in here, and then I can plug the USB of the fitness tracker in here. There is also one button. The reason for this is that if something goes wrong, so the fitness tracker hangs in the new firmware, so a boot loop or something else, we can reset it only from external by pressing this button, and this will connect the SWD EO short time to 5V plus. It's not great, but it works. I never had any problems with it, but I can recommend it. But for me it's the only solution for this problem, so if something goes wrong. And also, if you reprogram the tracker via the ST-Link, it is still in the debug mode after disconnecting it. And the reason that is bad is because it will draw around 3 milliampere of power until it is out of this debug mode, and you can only get it out of it by pressing the button. So resetting it, hard resetting it. A soft reset isn't working for me. It will still be in debug mode, and that was the main reason for this button. So every time I'm done with working on the firmware, I press this button once, so I reconnect or connect the DEO pin to 5V to reset it. Okay, but now I will show how I open the case and how I connect the pins to the SWD port on the tracker. For this I will get a little bit closer image. Okay, here is now the tracker, and I'm using my fingernails for it. They are long enough, and you have to try a little bit. I'm going inside of the USB connector here, so there is the case itself and also the plexiglass in front of it, and I'm putting my thumbnail between the plexiglass and the case, and now will very slow pull it apart, and you may already see the glue. And if we do this slow enough, the glue will just go apart, and we can reuse the glue for clothing the case again. So I'm now going around the plexiglass. And it will slowly get apart. This is a completely new opened tracker, so this is how it really looks. It is not already opened to make it look easier, so I had to pull a little bit of the glue, and so now we have here the bottom part left, and there I'm also just pulling it from the case. If something like here isn't correctly separated, it's not so bad. We can still use it like it is. So I'm now putting the front case away and will remove a little bit more of the glue so it doesn't go above the screen. So like this. I'm leaving it right now, and you also can see here the two touch buttons, and in the middle there is some light stripe you can see, and here on the right side is one path in the glass that is going on top. We cannot separate the display from the touch input. We have to desolder these two pins. That are the two touch buttons on the glass, and I will just show it in a minute. Yeah, so first I will unconnect this plug. It's for the heart rate monitor, and it is also glued in place. You can see here the black glue, but we can just take it apart and the glue will separate by itself. So like this. Maybe a little bit rework to get it better apart, but this will work. Then the next thing is, it's a little bit hard to get the PCB out because the two USB connectors are already here. This is a minus and this is a plus, the positive pin from the USB connector. But we will unscrew the screw here and get it at the right angle out. So I'm now using just a Phillips screwdriver and unscrewing one screw that is here. So like this. I'm putting it away for now. Now we can pull up the PCB on the bottom, and here we have to be a little bit careful because the plug for the heart rate monitor is still connected via the glue a little bit, but it will go apart after some separation. Then we can slightly pull the PCB up. It is still connected here to the two connectors, and the next thing I will do is I will pull it a little bit to the side, and while I'm doing it I'm resoldering or reflowing the two connections. So for that I will heat up my soldering iron. Okay, my soldering iron is now ready, and I'm trying to show it as close as possible, or as good as possible. We have to reflow these two PCB connections, and while heating it, pull a little bit on the PCB to get it out, like this. You can do it better, but it works like this. So now we have the PCB here, and you can already see the battery. We can also take it out or just leave it there. Then we can also see the two spare USB connectors. They are here and here, these two, and we need to remove a little bit of these gluey thing, so we can better solder the copper wire to it. This is a little bit hard to show on the camera, but you will see what I mean. So I'm removing the bottom part of it a little bit. Yeah, like this. And now I will put the tracker on my table so I can directly solder these copper wire to it. And for this I have some solder and of course a soldering iron. So I will first tin a little bit of the end. I have also this metal to remove the spare solder on the tip. And now I will solder or put a little bit solder onto the pins. This is definitely not so easy, but it is doable. Then let's turn it this way. I need to solder the copper wire as close to the pins as possible. But to show it on the camera, it's not so easy. Yeah, let's do this again. I need to put a little bit more solder on the pin. So like this, and now let's try it again. Okay, this seems to be good on this side. I will pull a little bit on it to see if it is successfully connected, but that looks great. Oh, good. So now I can cut the copper wire in an appropriate length. So like this, that's enough, more than enough. And now I will pre-tin the next part of copper wire and also solder it to the other pin on the PCB. Like this. Okay, that was too that was not enough. I will retry it. Yeah, that looks better now. It's really hard to see because it's all black, but still doable. Now I will cut the other part of the copper wire. And here I will show now a little bit of the PCB itself. You can see here the NRF52, the font chip, so also with 64 kilobyte of flash. This is the driver for the background LED, and here is the KX023, that's the acceleration module. Here is the battery charging chip. We have a vibration motor here. Here is the transistor for the vibration motor. We have the transistor, I think this is for the whole hardware to turn it on or off, so more power gets saved. Then we have one other transistor here to turn off the power if the battery is under a certain voltage. We have the oscillator here. Yeah, that's nearly all. I think that's it. Here on the front we have the PCB antenna, and also the light sensor here is just a diode, and yeah, it's just there. Okay, to continue this work we now have to desolder the touch input field, and for this I'm just going to reflow it, and normally it will just come by the tension to the top, so it wants to go from the PCB away. Okay, it's not completely apart. Yeah, I have to do it on the table as well. I will just put one side of the tweezer under the flex cable and pull it a little bit up. Now that's not working so well, yeah, but like this. Okay, now the flex cable from the touch input is desoldered from the PCB. You can see it here, and I need to put some force under the PCB because it is glued in place, and we need to go under the PCB to the test pads, where is also the SWD port on the test pad. You can already see that it is going to get apart, and I'm still applying pressure on it to get it, yeah, apart from another. But that looks pretty good so far. We can now pull it up and see all the descriptions of the test pins and all the test pins itself. Also under the screen are some more test pins. I will try to show it. Here you can see a few of them, but in my pinout I uploaded, there you can see more of them. Okay, now we have all the test pins here, and we need to connect our two wires to the SDEO and the clock to these two pins. And I'm doing it every time that I connect the right connector from here to the clock pin and the left connector to the DEO pin, so I can bring them to the front PCB, yeah, and they don't get crossed over somewhere. Yeah, so I will do this in a minute. First I will put the copper wires in the right directions. I will place them near the battery. It's hard to show, but we can do it. Put them in the side rail of it and bring them on top, yeah, nearly at the end of the battery. Here, this one on this side and the other copper wire on the other side. You just have to be careful that no wire is connecting any other pin. Here I'm pressing it a little bit down to the bottom and rework it to the middle. Yeah, like this. It's hard to show on the camera, but it's doable. Okay, so after this I will put the two parts together because we not need the downside, the bottom side of the PCB anymore. For this we can put it inside of the case again, the PCB. And while we're doing this, it is needed to solder these two USB connections back on again. I need to get the LCD display up again. One thing that's a little bit hard is that the vibration motor isn't going straight to the bottom, because there is some plastic in its way. We have to push it a little bit harder, like this. So it's now inside again, and we have both copper wires here, left and right. I will also reconnect the heart rate sensor plug. Like this. And now I'm going to solder these two connections back on again. They are now a little bit hard to get in, but yeah, it's also doable. You just have to watch that they are successfully connected. And while I'm soldering it, they are going a little bit down. So the whole PCB is moving a little bit into the case. And that's when I'm knowing I'm on the right path. Okay, this seems pretty good. As you can see here, on this side it looks better, on this side it looks not so good, but it is already soldered in to the pin. We can also test it. I have a USB connector here, and I will plug it in, and the fitness tracker gets charged, so we know it is working. So now I'm going to pull the display apart one more time to connect the copper wires in place. Again, I have to do it really slowly to not damage anything. It's really easy to damage the display because it's so thin, and I already did damage one of it. I just have to pull it slowly up. And the reason it's so hard is because here is a whole glue tape thing. Okay, now I'm going to solder or pre-tin a little bit the SWD pins. For once, this and the clock, like this. And then I'm going to arrange the cable in the way I'm liking it. So, for example, that no test pins are in the way of it. I will try to show it as good as possible. So like this. Focus. Then I will cut it here in the correct length, and the other part is going to be there. So like this, and then I cut it also somewhere here. Now I will pre-tin the ends of the copper wire to solder it better in place. So now they are both pre-tinned, and the hard part is now to bring them in the right direction onto the test pins while don't melt the case or something. So like this, and now I will push the cable a little bit down to the PCB and reflow it again to make it a little bit flatter or thinner for the display, because the display will rest on it. Now I'm doing the other side, first soldering it and then pushing it against the PCB like this, and now both connections are good. And so we can now close the display again. We can just put it in the right position like this, and now we have to resolder these two touch button connections. For this I will push them against the PCB with the tweezer and reflowing it in the right moment. Like this. And now they should still work. If I push on the top, okay, it doesn't work. It will work in a few seconds. The touch button input is with a certain threshold, and sometimes this threshold gets irritated by, for example, the soldering iron, so it doesn't recognizing any inputs anymore until it calibrates it to a new threshold like this. So now it's working again. It's a normal behavior of these touch inputs. And we can also see that the bottom touch input is working and the top input. Yeah, now the thing to do now is to replace the cover on top. For this I will try to make it a little bit nicer. For example, there's something on the screen, so we pull it a little bit to the side. And of course you can also make a new glue on it, but normally it works with the old one. It is a little bit rough. Yeah, I'm just putting the used glue on the right positions, and you can see it's still very stiff. Of course, if you if you put it together like this, the water resistance isn't there anymore. And also I of course need to put the screw back in place, but that would also work without it. So I will put it in the hole. It's easier with a magnetic screwdriver, but we will see. Okay, the screw is also in the right place. Now I'm gonna clean a little bit the screen because I touched it that much, and then we will see how it will work. So now the screen is nicer to look at, and of course I would suggest to test it out before you put it back together, but I will take the risk on me. To close it again, just put the top on it. Okay, now I'm seeing I have soldered a little bit the case here while I was reflowing the touch inputs, but you have to be careful. You can remove a little bit of the excess part. So now it's closed again, touch field isn't working like it should. Okay, now it's working again. Yeah, okay, so now I will try to connect it to the PC and will load the Android firmware on it, so you can see that it is working. Okay, the bottom touch input is really not that great right now. I need to get it apart again and see what it's wrong. So maybe it isn't successfully connected here. But that doesn't look so bad. But I will resolder it just to be sure. And we'll put a little bit more solder on the PCB or on the flex. So like this. So now there it is working. Yeah, this should be good. I'm cleaning the screen again. Like this, and now put the cover back on. Okay, so now the next part is reprogramming, and then we can see how this works. Okay, I'm now having the ST-Link, the adapter I made, and we'll connect it together, and also we'll plug the watch inside of it, or the fitness tracker, and I'm connecting it to the computer via USB, and you can hear that it will get recognized. And now I will show you a little bit more on the PC. I have the, let's turn that off. I have the sketch here for the watch, but that's now just to show you what you need to do to flash the tracker. You have to install the NRF52 library from GitHub, and first you need to select the right board, and you need to add my variant.h to the right pin definitions, and you need to select the soft device S13132, and after that you need to select here the programmer ST-Link version 2, and then you need to flash the soft device. I will now hold a little bit up to show you what is happening. And yeah, it's just said that the soft device is successfully flashed and nothing happens on the screen. I will now upload the sketch to the fitness tracker, and we also should see that nothing is working anymore on the fitness tracker, because it is now erased and the flash device is flashed. Oh my god. Okay. And also the flash device is like Windows. You can nearly compare it against it. And now the upload is done, and we can press the top button to go through the menu, and the bottom side, it's just don't okay, no, it's because the bottom side only is doing other functions. So for example, in the heart rate monitor, if I press the button part, it goes on or off, as you can see here, and it will then recognize my pulse or my heart rate if I leave it on there for long enough. As you can see now, the heart rate is pretty stable on the graph. Okay, so, and now as you can see, the time isn't set to the correct value. For that I need to set it via my mobile phone, and yeah, I will show that too. Okay, and to bring the fitness tracker out of the debug mode, I press the button on the back once, and you will see that it just restarts and the time is beginning at 0. But now it will discharge the battery so fast, because it can go into sleep mode correctly. Okay, and here's how I set the time on the fitness tracker. You can do it in another way, it's just my way of doing it. I need to get it back to light up properly, so like this. And I have this app that I created. It's just as an example. And we have every BLE device that is nearby, and I need to select the right watch. I don't know which one is mine now. And to set the time, I need to write alert level, and as you can see, the time in the second I press the button, the time was set. Yeah, but that app is not done right now. It's just to get it working. Yeah, but now you can see the time is correct. If we compare it to this time, it is, yeah, now it's done for now. We can reprogram the fitness tracker every time we want to with the ST link, and don't have to open it up again. It's, yeah, it's just ready to tinker with. Okay, that was my video about the fitness tracker E6 HRC and how to connect the SWD port to the USB connector. It's if you do it sometimes or more than once, it is pretty easy. You can order them on eBay right now for about 20 bucks, and that's, yeah, the cheapest price that is available right now. And it will take some time to get to you because it's from China, but yeah, it will work. And yeah, I will put it in the description so you can buy it yourself. Have a nice day!